So the recording has started. What we have here is in our session are a few things that I have on a PowerPoint slide that you can see. So we are going to start with data management or GIS data management in GRASS. What really is important here is that you have data import and export functions. You have your GRASS GIS regions. I'll explain. This is by far one of the most useful GIS related functionality that any software can have. You will be amazed by this one actually. I still use it a lot. I find it a very useful one. And then I have the GRASS GIS raster and vector information functions. So these again are definitely important, and we will do some introduction on that. Let's move on to our other window. Here are we're going to look at our OSGeo Live. If you don't have your OSGeo Live virtual machine, it does not matter. You can work on OSGeo shell, and you can just go into your Windows and click on GRASS GIS, and it will start. So if you're working on Windows, this is how it's going to be. Anything else that we do, like the commands and all, they're going to be available in here in the command line. So you will have no issues. Whatever I type on the screen would be available to you as commands in Windows as well. So this is how it looks like on Windows. And when we go to the Linux machine, let me fire that on as well. So this is my GRASS GIS window. And what we have here is this terminal that we will be using. You don't really need to use it to start GRASS. If you want to start GRASS, otherwise you can just go here, go to the geospatial desktop GIS and click on GRASS, and it will start it for you. I'll rather start it from here. So this is how my GRASS GIS software is. We last time saw how to change the workspaces that we are working in. So I could pretty much switch to another map set if I would want to, or I could just maybe remain on the same. So here I am switching to my Spearfish GRASS 70 data. I'll get a few errors here. All that you need to do is press enter, and the error will be like, you won't have an issue. And whichever workspace are you working in will be shown here. So you will have no issue as well. So if you are like in identifying which workspace are you working on. So if I go here onto my virtual machine, back again, I can see that I'm on Spearfish grass 70 data, and I can see that it's Spearfish grass 70 data here as well. Uh, I could list the files by typing g.list type, and it's gonna ask me, it is going to tell me, like, what I would do is there are a set of commands actually for grass that we use whenever we are working with grass GIS. The best approach for learning those commands is to mm, work on your grass GIS, work with your grass GIS panel here. And here you can actually type commands. You're going to get a list of commands that you could actually use in your grass GIS software. Since I'm teaching you, so I know these commands beforehand. For a new user, this is by far one of the most, I would say, difficult things to get a hands on. And many people get intimidated by that. They get scared by that because they think that there's so much of typing to do and so many of things to remember. But as you go on, you get a hang of it. So you will realize which command to use, when to use, and if you cannot find a certain command, you will know how to quickly search for that. So this is how it is organized. You could obviously work from the graphical user interface as well. So when I say that you can work from the graphical user interface as well, you have these commands in here as well. But it is for a very regular user, it is very convenient to use this terminal here. So if I go on to here and type on G that list dot list, it will tell me list available grass GIS database file for the user specified data types, optionally using the search pattern. Now here, this becomes very interesting because when you have to work with a lot of data, when you have too many files to work with, this makes your job far more convenient. And what you would do is you type g.list dash dash and help. When you do so, you will get a set of output on the screen, which will tell you what would you need to give the g.list command as input so that you can get the output that you desire. So when I type the g.list command and it mentioned that I want the type raster data to be listed, it will list all the rasters for me. I can press Q and exit. I could do it with the vector as well. And then I can continue pressing tab and it will show me like the space bar, sorry. So I press my space bar, it shows me the whole thing. And as soon as I'm done, I just press Q and it disappears. That's one function of GraphGIS that it does. There are times when you need to create your own workspaces. There are times when you need to create your own map set. So when you're going to create your own locations, workspaces here are called locations. So when you're going to create your own locations and inside them your map sets, you will be able to organize your data far much better. Today, what we're going to do is we're going to first create our location. It will create a default map set. We are not going to change that default map set. The default map set in GraphGIS is called permanent. So this is the permanent map set that is going to create. Uh, Other than that, it's going to create maybe one based on the user that I am. I do not know how it's going to do now, but let's see what it does. So I'll go to my sample dataset folder. I have a cd dash data. The folder is on my desktop here. It's here, the data folder. It comes with the software. Sorry, home, user, here. So this is the folder. I have some Lancet data Itasca data, NetCF data, Natural Earth data, North Carolina data set, some other rasters as well. I would maybe go with the Landsat data because many people are already aware of how Landsat data works. If not, there's nothing to worry about. We can obviously discuss that in our later sessions. So what you would really do is you're going to actually go into GIS and you're going to type r.in.gdal. So this is the command that you would be using. You're gonna type HELP. So in is for input, and GDAL is the GDAL driver that we are calling using GIS. So what happens here is that you are using raster, R for raster, in for import, and GDAL is the GDAL driver that you're calling, and help is for printing the list of inputs on the screen that is required by this command. So it requires an input band, it requires an output band, and if you would like to specify other things as well, you could do so. If at any point you see there is one thing that says location, so this is your new location where you're going to place your GIS data in. And this definitely becomes important because there is a time when users tend to need to place their data separately because they have different geographic coordinates. They are required for a different project they are working on. So when they're working on data for a different project, when they're working on data for a different area, it is better to create a location because this is going to be a geographically uniform location for all your files. So if I'm working on a certain city, let's say Paris, I would rather create a location for Paris and place all my data there. So what I would do here is I would say r.in.gdal, and I'm going to mention input. I'm going to go to the Landsat files, but I'll rather go to the Landsat files directly. CD and Landsat. Now I'm in the Landsat folder. I'm going to type ls. Then it's going to tell me which files do I have. So if I have a clip of band 1, a clip of band 2, a clip of band 3, and an SRTM file for the same region. So what I'm going to do is I'm going to first import the clip of band 1. So I'm going to type r.in.gdal-e. Now, why I'm typing -e is important because E here specifies extend the region extent. Now, this is the geographical region that we are importing. So what it would do is, for the file, the raster that I'm importing, it will expand my location's geographic region. So this must be giving you an idea of how organized GRASS is as a software. What it really does is, for whatever the geographic latitude and longitude limit of your import data is, it will expand it. If you don't use this E, so if you have like some previously imported data already there, it will cut it to that region only. So that's more like cropping it automatically for you on import. We don't need to do that. So what I'm going to do is I'm going to type E input clip one, sorry, 10.tiff output. I'm going to say base file because this is the first file that I'm importing, and I'm going to type location, and I'm going to give maybe a location name to it. I would say grass GIS exercise, let's say, or FOSS GIS exercise, FOSS grass, and I'm going to press enter. There you go. My file is now imported. Now, if I go into my grass GIS here, and I'm going to refresh it, I'm going to see that there is probably another map set created, and then there's another location created, and in that there is a map set, as I mentioned, permanent, which is the permanent map set that we have. All that I need to do right now is click switch map set, and now I'm going to be in the FOSS GIS map set. This is the base file that I imported. I could click on it and I can see this base file all together. And as I move my cursor over it, it gives me the geographic extent as well. I could type some r.info command maybe and type base file, the one that I just imported, and it will gonna give me the info for that file in a tabular format. This is the file name. This is the map set that it is in. This is the location that it is in. The database that it created was home user grass GIS. And over that, it has got a UTM zone mentioned, and it has got a projection detail, the zero, the minimum pixel value, the minimum value of data in it, and the maximum value uh, of data that it has referenced itself to. So this is what it has done. The next thing that we would be, of course, doing is we are going to be, we have we have four files altogether, but I can't continue importing one after the other, because if I do that, that would be something of too much to do. And since I want them all imported, and there are too many files sometimes that you're working with, so it would be more appropriate to import them all together. For that, what you can do is you could write a loop. So what I would do is for I in, and this is like the egu command, the key on the top left on my key of my keyboard, it types this command for me. So I'll type, sometimes I keep forgetting the name of this thing. So what I could do is I could probably go here and type, what do we call this? So it's not a caret command, it's something else. Uh, but this is some sort of a command. I don't know the name of it. Probably you could Google for yourself. But it's not an apostrophe, it's not a comma, it's not a single quotation mark. It is, I'm forgetting. I'm sorry, I wrote a document some time ago and I mentioned this, but now I'm forgetting this command's name. So this is what it's called, this command. So I'm going to type this one and I'm going to type it again and I'm going to type, no, sorry, I'm not going to type this. Sorry for that. Static.tiff. So I'm going to type static.tiff, and I'm going to say do r.in.jadal -e input. So I've saved all file names in this variable I here. And I'm calling this variable I here using bash. And I'm going to typing output is equal to echo $I cut dash d. Sorry, I'll not do that. I'll just type $I and I'm going to type done. And what it would do is it will import all files for me. Now, one thing that it did was it imported these files for me. And if I'm going to list my files, what I'm going to find is something slightly not very good. There's an extension alongside all files. And this is something that sometimes you do not want to show in your file name. It makes the file organization very clear. So what I'm going to do is I'm going to probably import these files again. But this time what I'm going to do is something different. So I'm going to press Q, get out of this window. I'm going to type G for I in G.list type is equal to raster, sorry, not this, for I in static.tiff do r.in.jadal-e input $I output, and I'm going to use these reverse commas that I have towards the top left of my keyboard here. I am using a QWERTY keyboard, English US, so probably it's going to be the same for all of you. I'm going to type output echo $I. I'm going to use this mod sign, the vertical line. This is towards the rightmost under the delete button. Cut dash D dot. So I'm going to use the D part of the name, the D dot, this part of the name. I'm going to tell my command to actually use this part before the D in the file name only, and do not use this part afterwards. So I'm going to A dash F1. So this is the first part, this is the second part. So the second part I want to discard, and I'm going to type done. The moment I do so, now it's importing the same files, but if you see, it's not adding the .tiff to it. So what it would do is, when I'm going to type g.list raster, I'm going to see that I have the same files imported, but it doesn't have the .tiff extension. Now I have double files. I want to get rid of these because I want my database to appear reasonably clear. So what I'm going to do is I'm going to press Q again, get into this window. I'm going to type for I in, but I need to remove those files. So for that, there's a command called g.remove. I'm going to type g.remove help, and I'm going to get the help here on the screen. So this is the command that you need to use for removing files. And it's got like type. You have to mention which type of file do you remove. You have to mention the name. Now I have several files to remove. I don't have one file to remove. So that's going to be a bit of a challenge because I can't type individual names here. So what I'm going to do is I want to remove all files which have a .tif extension from my database. I don't want these files in here. So if you look, if I refresh this one, I have these .tiff files and without .tiff files. I could right click and remove if I want to do that, but when I have too many files, I would rather want to do it quickly. So what I would do is for I in G, now I'm going to use these commands again. Dot list type is equal to raster pattern is equal to static dot tiff. So what I'm doing is I'm asking it to list all files that have a tiff extension, and I'm going to type do g dot remove dash f. So this is a force removal flag that I'm using here, force removal. So it will actually delete the files permanently. I'm going to mention the type, that is raster. I'm going to mention the name is equal to $I. It is saved in this variable I, this list of files with an extension .tiff. And since I know how the g.list command works, so I typed it directly. You will have to catch up with it. Then I'm going to say done. And the next thing that it's going to do is going to remove all these files. Now my files are cleaned. So I have clip 10, clip 20, 30, and SRTM. I don't want the base file to be there either because it's the same as clip 10. So I'm going to remove this, and this is not going to have any effect on my GRASS GIS location that I have here. If I refresh it, the .tiff files are now removed. Now I can obviously look at these files and see what can be done. So this is the other file, this is another file, and this is my SRTM file for the same area. The SRTM file obviously is an elevation file. I could actually profile a surface map for it. So I'm going to click on this here just to see how it is. Draw a line, and it will create a surface profile for me. I can export these values if I want. So this is a very good additional functionality that GRASS GIS has. It actually creates you on the fly very good looking graphs. And if you don't need to actually use this, you could just, click on this and it will save this data for you in your downloads as a CSV file. So these are the elevation profile. I'm moving a little fast because I have a few more things to cover. So I'm going to go into my downloads. And this is the elevation profile that I just created. I can open it here, and this is along the points that I drew that it has a geographical profile values mentioned for me. So most of it is at sea level, so that's 0, and in some places it is above sea level, above to 17, 20 meters. Anyhow, I'll close this function as well, and I click close. I'm going to press Q here and get out of this window. And now I'm going to get you